Hi there. So let's go ahead and start a brand new page in our notebook. And we're going to title the top Solving Systems by Graphing. So I shorthanded a little bit. What I mean is solving systems of equations, which means we're going to have two or more. But our first technique that we're going to do is going to be by graphing. So let's first get this problem set up. Okay, and then what I'm going to have you do is we can put the sticker in that I gave you in class for the coordinate plane. So example 1, this is going to be a no calculator problem. The first two that we're going to do in this video is we're going to do non-calculator problems. And then I'm going to, when you come to class, I'm going to show you how to solve these in your calculator. So here's the system. It's 2x minus 3y is equal to 18. And 4x plus y is equal to 8. All right, so hit pause if you need to write everything down. And you know what, before we get started, why don't we go ahead and put in that coordinate plane sticker, and let's get our coordinate plane set up. So I think if we, scooch the y-axis over here, and if we put the x-axis about here, this should give us enough room to graph our lines. All right, so getting started, I'm going to basically kind of get line number 1, and I'm going to get line number 2 in slope-intercept form. And so I'm going to come down here, and let's rewrite 2x minus 3y equals 18 into slope-intercept form. So we're going to subtract 2x from both sides. Now don't forget about the minus that's in front of the 3. It's going to mean this is a negative 3y. I'm going to put the negative 2x first and then put the plus 18 so that when we write this, it's in slope-intercept form. Each part by negative 3. So y equals negative 2 divided by negative 3 is positive 2/3 x. 18 divided by negative 3 is going to be a minus 6. And this is the equation that we are going to graph when we're ready. So let's get equation number 2 is going to be 4x plus y equals 8. And so this is just one little simple step of we're going to subtract 4x from both sides. And so again, be careful with this though, because if we don't write our equations correctly, then we're going to graph them wrong, and all the work after will have therefore been incorrect. So there's my two equations. Let's go ahead and let's graph the first one, which is y equals 2/3 x minus 6. All right, so y-intercept of negative 6. 1, 2, 3, 4, 5, 6. All right, from here we're going to move up 2 and to the right 3. Okay, 1, 2, 2. So I'm going to continue moving the slope up 2 and over 3. And really, we want to get a lot of points because that's going to be the best way to ensure that our line is straight. Okay, if you don't have a ruler, we want to graph as many points as possible to make our solution as accurate and as easy to see as possible. So now we're going to graph our second line, which is negative 4x plus 8. 1, 2, 3. Okay, so we got a y-intercept of positive 8, and from here we're going to move a slope of down 4 and to the right 1. Down 4 and to the right 1. So I can see here that if I keep going, it's going to eventually cross the blue line. Let's count one more time. 1, 2, 3, 4 over 1. In fact, right there, I can see is where the two lines are going to cross. And so let's draw in the lines. Okay, let's not just leave it as a bunch of points. And there's my two lines. What we're looking for are where the two lines intersect. Right here is the solution. And so what we do is we write our solution. You know what? I'm going to pick a better color. I feel like that green's kind of hard to see. So what we're going to do is we're going to take our solution and we're going to represent it as an ordered pair. Okay, so our answer is going to be the ordered pair 1, 2, 3, 3, and then 1, 2, 3, 4. Okay, so 3, negative 4. And what that means is that if we plug 3 in for x and we plug negative 4 in for y into our original equations up here, that both equations will therefore be true. So that's the basics of how it works. Hopefully that was a little review session for you. But let's go ahead and go on and let's look at another type of problem. So example 2. Again, this is going to be another no calculator. All right, so here's our system. 2x equals y minus 3, and then we have 4x minus 2y is equal to 10. Okay, I think we're going to be okay not having a coordinate grid for this. I think you'll see why at the end here. So again, I've got line number 1, I've got line number 2. Our first job is to carefully rewrite each equation into slope-intercept form. So here's what I'm given. Now, I think that if we started, we could maybe add the 3 over, and we'll have 2x plus 3 equals y. So I'm just going to turn this around so that we can get the y first, like we like. This is the line y equals 2x plus 3. Now let's go ahead and write our second line in slope-intercept form. 4x minus 2y is equal to 10. Subtract 4x from both sides, and we see that it's negative 2y equals negative 4x plus 10. Let's divide both sides by negative 2. Okay, we're going to divide each part by negative 2. And we get y equals negative divided by negative is a positive 2x, but 10 divided by negative 2 makes negative 5. And these are the two lines that we're going to graph. Now, I think we're going to probably do okay if we just go ahead and set up our own coordinate plane. Now, before I get started, I'm going to go ahead and I'm going to, mark off some units here. I kind of find that if I do this first, I tend to make them more evenly spaced than when I try to do it as I'm graphing. And of course, when you're doing this, in class or for homework, I'll give you a grid. So let's graph our first line, the blue one. So we start with our y-intercept of 3, and our slope is going to go up 2 and to the right 1. Now we can go ahead and reverse this and also move down 2 units and to the left 1. That will also make our slope a positive 2. So when you feel like you have enough points there, okay, definitely get at least 3 or 4. Let's go ahead and let's graph this line. Let's graph the line that's in red. This line has a y-intercept of negative 5. But again, we're going to move up 2 and to the right 1, up 2 and to the right 1. So I'm going to do this a couple times. So what kind of lines are we seeing here? Well, we have 2 lines that are never going to cross. And what are those called? These are parallel lines. And if they're parallel lines and they never cross, that means that we are going to have no solution. Okay? So we could also have our third case, which is infinite solutions, which we'll talk about in a second. All right, so that's what's happening there, is that we've got 2 lines that never cross, and so we're not going to have a solution. This would be a good time to actually recap our 3 types of solutions before we get to our last problem. All right, so we've got 3 types of systems that we're going to see with our systems of linear equations. Okay, 1, 2, and 3. All right, so our first type is going to have 1 solution. Our second type is going to have no solutions, and our third type of system is going to have infinite solutions. Okay. Well, a no solution is what we saw in example 1. That's where we've got 2 lines that cross, and they cross at 1 point. Okay? So if we have 1 solution, we would then represent our solution as an ordered pair x comma y. Now, if we had no solution, it's because we graphed 2 lines, as we saw in example 2, and we would see that you have parallel lines. Okay, so you have 2 lines that would never cross. Well, infinite solution's a little different. Infinite solution would happen when maybe you graph the first line, and then you go to graph the second line, but the second line is right on top of the first line, and so that it is the same, okay, it makes the same line. So I'm going to make a note right here, because when you put this in pencil, it probably just looks like there's 1 line. And this would be infinite solutions, because if it's the same line, then they touch at an infinite number of points. What I want to do as a final note going through is I want to talk about what must be true about the slopes. Okay, the slope of when you have 1 solution is the slopes of the 2 lines, okay, are different. The slopes are different. If we have no solution, then the slopes, okay, are the same, but the y-intercepts, okay, are different. And that's how we kind of, we should have, when we were doing this, we should have been able to identify earlier on that it was going to be no solution, because I can see right here that I have the same slope, but since the y-intercepts are different, that's what maybe would have told me that I was going to graph parallel lines. But with the same line, you end up with the slopes and the y-intercepts, okay, are the same. And so it is an identical line. And we'll see some problems in class that are going to use that information that we just wrote out in red. All right, so I'm going to finish this set of notes with one more example, and then when we come to class, we're going to learn how to solve these into our graphing calculator. All right, find M so that the system has no solutions. And here's what we're going to be given. 4x plus 5y is equal to 5. And this is going to be the equation y equals mx minus 2/3. Okay, so with these, what we need to do is we need to find our entry point. And since we just talked about the slopes and how the slopes are changed depending on if you have one solution, no solution, or infinite solution, I think a good strategy for this would be to rewrite both equations into slope-intercept form. So I'm going to take this first equation that was given, and we're going to work to get this written in slope-intercept form, because it's the slope that's going to help me decide what this m should be. Negative 4x plus 5. Now we're going to divide each part by 5. Okay, so here's the first equation written in slope-intercept form. It is negative 4/5 x plus 1, because it's 5 divided by 5. Now, if I take a look at this equation that was given to us, I'm going to take this, and I'm just going to bring it down, and I'm going to write it right underneath it so that I can compare. Now, to have no solution, that's because the slopes are the same. And so if this has a slope of negative 4/5, then this slope must also have a slope of negative 4/5. The y-intercepts need to be different, which they are, so I'm not worried about the y-intercepts. And what we can find right here is that the m must equal negative 4/5 so that the lines are therefore parallel. Okay, so you'll answer a couple of questions like that, abstract. Well, that is it for now. We will come to class, and you know what I'm going to do? I'm going to actually already set up example 4 so that I can tell that you watched these notes. Number 4 is going to be a calculator example. All right, and so here's the system. 5y equals 7x plus 1, and this second equation is going to be negative 1/4 x minus 19/4. Now, you can go ahead and shut off these notes. We are done for the day. We'll pick up with example 4 when we start class, when I see you next time. Bye.